what I'd like to talk to you about is responsible information sharing. Our office was created after the attack of 9/11, and the whole notion, it's very basic, is that the country was in possession of information that could have enabled proactive defense and protection against the attacks that happened. And 9/11 Commission and the passage of laws says, let's not have that happen again. But I want to extend that more broadly into the geospatial community and other mission areas as I talk to you this afternoon. A lot of the presenters talked about the potential value of using readily available information for business products and business value, and this is a lot of the same thing. But what we're supposed to do is enable that to happen across these 5 communities you see on the y-axis: law enforcement, defense, intelligence, homeland security, and foreign affairs, diplomacy. We're supposed to do that across not just the federal government, but with state government, local government, tribal, private sector, and international partners. And this was established originally to share more effectively terrorism information, homeland security information, more recently cybersecurity threat information. And you see at the bottom there the absolute reliance on all of that on the technology industry, because all of this information is riding on the hardware and the software that we buy from the private sector. And for it to work, it has to be an effective public-private partnership. And so this environment, in common terms, people would call it an ecosystem. It's just the organizations, the systems, the people, the data that all have to work together effectively so that information gets in the hands of people who need to make decisions to enable them to do it better, to make better decisions, do them faster, and to have greater program effect and results in the end. This applies not only to just open data. I heard a lot about open data. I was at the White House when we built data.gov about 6 years ago, and a lot of the initial open data for the US government, at least, was geospatial information. It was already available, and it's being widely reused. It's not just open data. When we start talking about law enforcement information, or financial information, or health information, or classified information, we have to bring in responsible sharing means authorized access to people who have a right to know and a right to use information, and prevention of unauthorized access. And the good news for us is the same technologies in things like identity credential and access management, automated policies that enable proactive sharing also prevent unauthorized access. And that includes geospatial information. I'm going to talk in a minute. The other reason is that in having lived through the era of post-WikiLeaks and post-Snowden, I really encourage people to think very carefully about not only insider threats, but external threats to the information that you possess, whether it's your intellectual property, whether it's national security information. There's plenty of malicious actors out there nowadays that will do mayhem with your information if you let them. We found that this whole success of this model is built on a reciprocal trust model, but it has to be a scalable one. It's okay if I know Mark and I trust Mark, and I'll share my information with Mark, and vice versa. That's one-to-one. What we're dealing with across the country is 18,000 law enforcement agencies. That's just law enforcement. There's 750,000 law enforcement officers. There's several million emergency first responders. We've got all the federal agencies with thousands and thousands of people. I can't apply my personal trust model to millions of people that need to work together. So how do I do that? A combination of policies, technical solutions, compliance mechanisms actually can enable an at-distance second and third party trust relationship, again, for including things like geospatial information, to be shared with trustworthy partners and blocked from others. What we found from talking to state and local law enforcement officials, national security officials, is they're facing a set of these common challenges you see down the left-hand top of the slide. The threats are not changing. We're not fighting the same fight today that we were fighting, on 9/11. Cyber threats are changing. Violent extremism in the homeland's changing, and there's a geospatial dimension to that. Collaboration. Every organization I talk to nowadays says it's no longer a world where we can go it alone. I heard a lot this morning about the ecosystem of collaboration in the industry. That's exactly what we're seeing. Public-private partnership, that's exactly what we're seeing. Nobody goes it alone in the global environment and succeeds. So we've got to figure out how we can do that we think some of the common operating models, standards for interoperability you heard about earlier, enable that collaboration to succeed. Enterprise data management, talking to the choir here about that, I would really highlight the last thing at the bottom of that slide that is fundamental, at least in this country, much of Europe. The assurance of individuals' privacy and civil rights and liberties in the conducting of business using technology is essential. We don't get away with not doing that. We get sued to a screeching halt if we fail to do that. So here's 6 parts of our portfolios. We call them mission focus areas that I would illustrate the importance of geospatial technology just in our world. And I actually have a natural resources background, and it was equally essential there. The state and regional information sharing. The idea is to replicate the national model at state and local levels. Intrastate, interstate, between the state governments and the federal government. A really good example that we heard about law enforcement earlier is place-based policing. Place-based policing is about analyzing patterns of crime so that you know where to deploy scarce police resources to prevent or detect and respond and investigate and catch criminals where they concentrate, because there are geospatial and temporal patterns to crime. The cyber information sharing that we're dealing with nowadays is we can make a much more sophisticated analysis if we don't just look in the telecom network at cyber threats, but we also connect it to the physical location of the devices as well as the perpetrators of cyber malicious activity. Watch listing, screening, and encounters is about our core counterterrorism message. It's probably obvious that we need to know where they are to be able to interdict them and prevent them from doing harm. Domain awareness is a pretty interesting one for us because that includes the 17 critical infrastructure domains. One that we've got that's really active right now, I heard about earlier today here, is the maritime domain. There's ships, thousands, moving around the planet with thousands to millions of people on board, crew, the cargo, the passengers, and that's inherently a geospatial analytic problem all the time, every day. We have very strong interest in our international partners for handoffs of that information between us as ships cross international boundaries and enter ports for them to know what's coming and be prepared. It also includes all those different critical infrastructure sectors that you hear about under potential attack all the time. Our power grid, transportation, chemical industry, all of them are geospatially enhanced if we applied that capability. Transnational organized crime, again, with a crime pattern that we watch people, whether it's smuggling guns, gangs, drugs, terrorists. As long as it's international, there's a strong handoff partnership with our international partners for that. And the last one is incident management, and there's quite a bit of activity. I was impressed in some recent conferences seeing the level of common operating pictures that firefighters and police are able to assemble now with the technology tools themselves. That used to be, I have to go find a GIS wizard, build me an application, and a year or two later, maybe if I have data, I've got capability. These guys are knocking together operating picture environments with application development capabilities in days and hours, and they're using them on the ground to improve their mission performance. So the value proposition we believe in this space is, if we can aggregate customer demand on the one side, in my world that's getting all those organizations you saw around one of those mission areas to say, we have a common set of requirements. We need to stop a bad guy from doing something bad, and we need to catch him before it happens. If we can aggregate those requirements and translate those requirements into a common set of technical exchange specifications, then we can turn to industry and say, build this. For this to work, we have to involve the industry in what we heard earlier. What's feasible, what's possible, and what's not. We can't put out requirements that are not possible, they're not affordable. On the other hand, we have all the time people from industry coming and saying to the government, why are you 5 and 10 years behind? Why are you not taking advantage of the current capability to improve your program? What works in the middle of this model is things like the standards development organizations. You saw some slides earlier. We've worked with Mark on OGC for geospatial standards. It's not about eliminating competition. It's not about picking winners and losers. Whatever the solutions are, that ecosystem has to all work together. And the interoperability is driven by the standards inherent in the technology. If you think about the whole OSI stack, well, we got the telecom packets going back and forth, and you can go all the way up. But up at the application level, The actual semantics and exchangeability of the information between us is essential to me to make sense out of your data and vice versa and get value out of this ecosystem. So we built something that we called the Standards Coordinating Council. We're fairly proud of it. It's in effect for about 1.5 years. We're hoping to really get some value out of this. Because what we were finding is one community was really heavy in one standards organization, and they were good with each other. We heard about the police this morning, the International Association of Chiefs of Police. There's a very good, strong user community across the country, common set of requirements. But they weren't covering across the different technology communities, the different platforms, and getting unity and interoperability out of the industry on the solutions in the records management systems, in the computer-aided dispatch, and certainly not when they were taking non-spatial applications and trying to bring spatial capability and platforms into that environment. So this group has been in effect for a while. They're trying to develop standards. I would highlight that we do have OGC in there as an enabler of geospatial interoperability. IGES Institute's in there for justice information systems. OMG's in there that's working heavily in the industrial Internet of Things. So there's a lot of the technical expertise needed to make all these different communities work together effectively. We put together an interoperability framework, an architecture, and broke it down into what we're calling project interoperability. The bottom of the left-hand side of that slide is you need to have a certain amount of management. You have to have authorities and policies. You got to have a place to meet. You have to agree to work together in a common way, plan, execute, communicate, and all that. Soft skills. Down the right-hand side is common patterns that we see are essential to interoperability. A couple that I would highlight, again, especially if we're handling anything other than wide open information. It's essential to have an identity and access management model underpinning your technology. I need to know if you want access to law enforcement information, if you're a law enforcement officer, do you belong in there or not? I need to have a common set of data attributes that I can automate the policy and say your identity is authorized to that information, his identity is not. And then I can enable information sharing at machine speed on that environment. I would highlight the fact that we have geospatial in there as a cross-cutting enabler of those mission areas that you saw earlier. This one, what I'm trying to illustrate with this slide, across the bottom is sort of an increasing number of people and participants. If I go to wide open data on the far right, or anyone on the planet, it's got the lowest level of safeguarding inherent. As I come back further upstream, I have fewer and fewer people. I can go inside government, I can go inside federal, I can actually go inside specific agencies, and the safeguarding level goes up as the things like classification level goes up. We're required under law to make those cross-domain capabilities happen because, believe it or not, the intel community benefits from open source information. The private sector benefits when the government can say your security, cybersecurity is about to be attacked by so-and-so. This is for us sort of the holy grail over the horizon. If we can actually get cross-domain collaboration between these communities, we're going to get more mileage and value out of the data that's already out there. This is probably an eye chart in the back of the room. It's just intended to demonstrate that we have enormous range of technical capabilities now, but for the value to be realized from them, we've got to have the interoperability between the communities and the technology so that stuff all works together. And I was really impressed with hearing the part earlier about abstracting the complexity. We can have sophistication in the systems. We have to abstract the complexity for its use away from the end user. It's got to be quick, simple, easy. If you think about one of the examples they gave us to figure out, we want to help firefighters. Obviously, a geospatial, building information management, you can think of wonderful things. But wait a minute. The guy's got a uniform, a suit on. He's got a helmet on. He's got goggles on. He's got gloves on. So, okay, your user interface with your fingers, that doesn't work. He's running power equipment, he can't hear. He's got a face mask on, he can't see because he's in the smoke. His device just burned up because it's 700 degrees. Now solve this problem. There's a user requirement you have to adapt to. To help put this stuff together, we've built something called a geospatial interoperability reference architecture. This is a government slide where there's higher level architecture. Point is, there is one for geospatial technology specifically. It covers business process, data models, security models, performance models, And the whole idea is it's a frame. It's not a specified architecture. It's a framework to help people make this stuff work together. It's available. It's on a public site. We are sponsoring a project for the FGDC to take over stewardship and try this thing out and really build out applied examples and see if it works and will help promote interoperability in the future. And one last example I would offer is we did a mini version of something like that in a project called GEO for NIEM, National Information Exchange Model, because what we found was the law enforcement community was over here for years in XML-based information exchanges. The GEO community was over here with geospatial markup language, and there was some incompatibility between the two. Well, what happens when the law enforcement system says, I've got this perpetrator at this geolocation and I want to see where that is on the map? Or the GEO says, well, here's where the crime is happening. What do you know about it in your record system? If you don't have the compatibility, we solve that with a bidirectional exchange by applying these architecture design principles, and we now have capability back and forth. I'd refer people to OGC's Testbed 11 as the proof of that concept.